Okay. Good afternoon. So we remind you with the lab test 2, March 4th. You have 2 lab sessions. If you are registered in the morning one, please attend the morning one because the lab already set up for your ECS account to be in the morning. If you register to the second one, you have to attend the second one. Okay. Now, make sure this time is already marked in your agenda. Don't forget about the lab test 2. It's weighted 15%. Okay, 15%. And still we have lab test 3 at the end of the March. But now let us focus on lab test 2. At the end of these lectures, we will talk a little bit about lab test 2, but also in Thursday we will talk more about lab test 2. Previous lecture was before the winter break or winter reading week. Okay, we cover aggregation and compositions. Aggregation and compositions will weighted more like 70% of the lab test 2. So understanding aggregation and compositions is essential to have a good grade for the lab test 2. Today, lectures will be discussing generic and interface. Continue back to generic interface. Will help you to do the lab 4. Lab 4 is also with the lab 3 are very essential to have very good grade in the lab test 2. So my recommendation to you is to take the opportunity to look at the lab 3 and lab 4. There will be no extension for the submission for the lab 3 and lab 4. We will post the solution immediately after the deadline. So the students, they will have a chance to look at the solution of the lab 3 and the lab 4 before the lab test 2. So make sure you read lab 3, lab 4 carefully and try to implement them and solve them by yourself. If you are working with teams, try to be involved. Don't just sit and watch other people do the job for you. Also, another part of this lecture today is how we use the collections, how the collections are built on Java. Okay? Let us start. So interface, whenever you are looking at an interface, interface is used as a reference. We cannot create an object from interface. We can use the interface as a reference type. Okay? It contains only the signature or the header of the method and some additional constants. There's no body, there's no implementations inside the interface. Interface does not contain any implementation. It just contains the header and some methods are defined on it. You cannot create an object from the interface. Whenever you decide to implement the interface, you have to say implement interface. So the class can implement the interface. Class cannot extend the interface. Another interface can extend an interface, but classes normally implement the interface. Another interface can extend existing interface by adding some additional methods. All the methods in the interface are automatically public abstract methods. And we're going to come across later on about what we mean by abstract. Okay? So even if we didn't mention that this method is public abstract explicitly on the interface, all the methods inside the interface are public abstract method, even if we didn't mention that. This is an example about a drivable interface where it contains only the header of the methods. And what we call a header of the method, if you remember, it's behavior, because the method represents some certain behavior for the object. Here we have a drivable object. There's a 4 behavior for this drivable objects, or we can say methods. Whenever we are discussing an object-oriented, we say constant that carry informations. It's called data, will represent the state of the objects, and methods represent the behavior, how the object is treating and interacting with these data and with the outside world. So we have a method start, forward, 10 with some angles as input arguments, and stop. So this is an interface, public interface drivables. Now we have a class that implement this interface called bicycles. And very simple implementation just to demonstrate what I mean by interface and implement. So once we decide that bicycle class implement the interface should provide the implementation for the 4 methods. You cannot skip any one of these. If you skip any one of these or forget one of these, the compiler will give you a notifications. So you have to give me an implementation for these 4 methods, in addition to any other method you like to add to the object bicycles. But once you decide that bicycle implement drivable, you have to give me an implementation for a start, forward, 10 with some angles, and stop. Another class is called car. So both bicycles and the car, they are shared some kind of common that they are both are drivable. So both are implement the drivable interface. Here we have a car, and we have an addition to the implement of this drivable interface. There is some field called the car name. We give a string name. So we ask constructor to assign the field, and also we have a start for the car, forward the car, turn the car, and stop the car. Now this is the diagram explain the relation between bicycle and car as a class with the interface drivable. So both car and bicycle implement the drivable interface. Now this is a test. We define a new car. We give a car A. We start car A forward. We turn the car A. Then we define another car. It's called car P. I would like you to focus on the declaration and reference type here. In the first, for a car A, we have a car A. So we have car as a class, and this is the declaration. Okay, this is the reference. It's a car object, and we create a new car. But in the second, for a car P, I use a drivable as a reference type. So I can create a car object and assign it to a reference of type drivable. So the same thing, I can use car P to create a new object of bicycle. So drivable is more like common between the bicycle and the car. So I use a drivable for a car P as a reference type. So I create an object of type car, and I assign it to a reference type of a drivable. And I start A and start P and forward B and turn P. So this will be the output in case of you execute this inside the Java. The main idea here is that using a drivable as a reference type. Okay. Now, can anyone define like this? If I use drivable car equal new drivable, can I do this? Based on our previous discussion, we cannot create an object of interface. So this is illegal. We cannot do this. We can use a new car, new bicycle. We cannot create an object from interface. So this is illegal. We cannot do it. Okay? Compiler will give you a warning. You cannot create an object from interface. This is a check exception, or compiler will check it for you before you execute your program. So you can use a drive on the left-hand side, but you cannot use it with the new operator. So new keyword, you cannot use interface with it. Okay? So just to summarize what we mean, all what we discussed, is interface contain method declarations and sometimes contains some constants, and all the methods inside the interface are public. All of them is public abstract. We cannot create an object from the interface. and we can implement the interface. And once we decide to implement the interface, we have to provide the implementation for all the methods inside this interface. As you saw in the previous example, turn, forward, start, stop, all these 4 methods should be implemented once you are implementing the interface. And the class can extend a single class, but can implement many interfaces. And this is what's the beauty and the one of the strong points on the Java. You can create as many as you want interfaces, which contains a behavior, and you can implement this behavior for the object. So the object can implement many behavior, but whenever you come to the inheritance, it's a single. Each class has only single parent. We're going to come across that later on when we discuss the inheritance. Now, just to make it more like comparison between the regular class that represent an object and the interface. Both are user-defined. You can define the interface as you define the class. Both have set of methods, but class has some another data represent the state of the class because you create an object. Okay, if the interface could represent a behavior, more like a behavior, all the thing inside it is behavior. No implementation is provided inside the interface, but all the methods inside the class should be implemented. You cannot leave anything without an implementation. Now, you cannot create an object from interface. This is an example. You cannot say drivable car C equal new drivables. Okay? But classes are meant to be for an object, to create an object from the class. Okay? Now, one of the things that we have is a sorting. And we have sorting interfaces. That interface compare between objects and sort them based on some kind of order, not for equality, not to say that this object is equal to that object, but is to say that this object come before this object or come after that object. So we have array.sort and we have a collection.sort. And array.sort, arrays and collections are utility class. You cannot create an object from arrays. You cannot create an object from collections because they are utility class. They have the private constructors. Now, but they have some kind of set of method to manipulate arrays. So we have here array.sort and collection.sort. These are depend on the implementation of compare to and sometimes comparator interfaces. We'll discuss them now. So user-defined types is comparable interface and comparator interface. If you decide to use arrays.sort or collection.sort, you have to provide an implementation for one of these. Okay? Comparable interface you are familiar with. You have to implement compare to. Comparator is another way to define for the object to be sorted. We're going to explain this. So a comparable interface that you are familiar with is relying to the standard way of comparing the object by implementing compare to inside the object. So here we have comparable interface, and you can see between the angle bracket T, that means generic type, and we are comparing any type. Once you decide to implement comparable interface, there is only one method inside it. This interface contains only one method, and this method is called compare to. Okay? You decide to implement comparable interface for any object you create, you have to give me an implementation for compare to. Okay? So let us see. Here we have York 2D point. I decide to change the name for York 2D point. Implement comparable, and look at the between the angle brackets. In the previous slide, we have T capital. T capital is a generic type. Now, once I decide to implement the comparable interface, I have to give a type. What I'm trying to implement here? I'm trying to implement a comparable interface for my object. What is the name of my object? York 2D points. So that is where I replace T with York 2D points. Now, I decided to implement a comparable interface. That means I have to provide an implementation for compare to. My class contains private integer x and y. I have a constructor for x and y. Get x, get set x, get y. So notice here, as we mentioned, implements comparable, the name of the interface, and we give the T as a generic with the type that is your 2D point. Now we have set Y to string and distance 2, and we have to give distance to the between this object and some other point. So all these is a method inside our object. This is how we define the object, a class of type object class for your 2D point. So we have X and Y, we have a constructors, we get X, get Y, set Y, and also we have toString to print it out for the user. And also we have another method, it's called public, its retain type is double, distance to some a certain point. We give a point, others, and we calculate the Euclidean distance between these 2 points, the distance between this point and the other point. Okay? We take x squared plus y squared under the square root, and that is the formula. But we didn't finish. We have to provide compare to. The compiler will tell me always you have to implement compare to because you decide to implement comparable. Now we have to implement the compare to. We have to stick with the same signature, public integer. The retain type is integer, and we give a your 2D points because that is the T capitals. And here we are comparing these 2 points. First, for x, we look at the x. If the x is coming before the other x, that means this is the order. If that x is the same, they have the same x coordinate, we look at the y coordinate. We sort based on the y coordinate. So this is the way of sorting. Someone say, I will sort the points in such a way that I will look at the x coordinate, okay, sort based on the x coordinate. If the x coordinates are equal, that means they are on the same line, okay, so I will take the y coordinate. I will take the y coordinate. Now, he defined a list of type ArrayList and start adding a point. Create 8 and 3, 6 and 3, 2 and 15, and 1 and 1, and minus 1 and 1. And then he tried to print the points out and then ask collection.sort to print them based on some sorting. Now, once the client decides to use collections, collection is a utility class, and sort is one of the methods. Do you think if we didn't implement a comparable and we ask .sort, what will be the output? Unpredictable, because we have a class without implementing a comparable interface. So we rely on the objects, okay, and behavior of the .sort will unexpected. Nobody can know till, because different machine can give you different output. But once we agree that the York 2D point implement the comparable interface and we provide compare to implementation, as you saw in this slide, when I ask collection.sort, it will use this method. It will look inside York 2D point and, oh, your 2D point implement comparable interface, so it will rely on what? Compare to. So what do you think the output? Can anyone guess the output based on what we have here in the implementation for compare to? As you can see in the implementation, we look at the x coordinate first, then y coordinate. So which point will be first printed out if we sort the list and print it out? Which point? Minus 1 and 1. That's the first one. The second one, 1 and 1. The third one, 215. And the third one, 8 and 3. And the last one will be 9. Okay, so here is we print the unsorted, and then we sort the array based on compare to. Why we are sorting based on compare to? Because we create the object, and we implement comparable interface, and we add compare to implementation for our objects. So our object can be sorted, and we're going to see that is minus 1 and 1, 1 and 1, 2 and 15, 8 and 3, and 9 and 3. As we, there's nothing different here. There's no, everything is determined Why? Because we implement the compare to. You take this, run it in your machine, run it in his machine, everything will be the same. Because we implement compare to. Okay, any question? Before previous slide, not this slide. Okay. Here, at override. This is a notation. It's good for readability to tell you that compared to, it's overwritten here. This compared to is existing somewhere, but we override it. It's part of the style that we are using at 2030. And I encourage all the students to stay with this. Otherwise, you will forget that if I remove compare override, nobody knows that this method exists on other class. I'm just overriding it. Okay? You understand me? This is for readability. And I encourage all the students to keep this annotation whenever they decide to override a method. And we're going to come to the topic of inheritance where we're going to override methods a lot. So we need to know that this method exists on the superclass and we just changing the behavior for our object. We change the behavior of compare to be suitable for your 2D point. Okay? Now we come to the comparators. What if we decide to sort the points in different way? As we saw in the previous slide, we sort them based on the x-axis, then y-axis. If someone decided, no, I need to sort x, then y, I need to sort y, then x, or someone say, I need to sort based on the distance. How we can do this? Because according to what we saw, comparable interface provide me with only one method. So every time I change the way of sorting, I have to delete compare to and create a new compare to. It will not good practice. Okay? Imagine that I have to sort the points based on the distance of the origin. That means I have to go back to the previous slide, delete whatever I wrote, and wrote again another compare to implementation. So my point now, your 2D point, will be sorted based on distance to the origin. Java will say, you don't need to do that. We have created another interface for you. It's comparator interface. Comparator interface is a generic type, again with T. T capital is a generic type. You can implement comparator interface as many as you want and use it to sort the point in different ways. Okay? The main common way, you can implement it on the compare to. But whenever you decide to compare with different criteria, implement comparator interface. Let us see how we can do this. So, interface comparators is a generic interface. We have a T capital between the triangle, okay, and it's take two arguments. It has only one method to retain integers. The method is called compare, and it's take two arguments, not only one, tx, ty. So you give 2 points of the same type, you calculate the distance between them, or you compare between them, and you retain an integer. Okay? It has only, again, one method is called compare. Here is the implementation of comparator interface to calculate to compare between your 2D point based on the distance to the origin. I say I create a class called distance comparators, implement comparators, and I give between, replace T capital with the object that I'm trying to implement comparator for. It's your 2D point. And inside it, I define a private final York TD point and origin, because always I'm going to compare with the distance to the origin. I define a new point with 0, 0. That is my origin. And here I put at override to indicate that I'm overriding this method. for the readability. And public integer, compare. I give York to the point. I replace T capital with the same object, York to the point, 0.1, York to the point, 0.2. I calculate P dot distance to the origin. You remember the object York to the point contains a method called distance to. So I use distance to origin, D1, and I use distance to the origin, D2. Now I have the double, D1 and D2. I use D1 dot compare to D2. D1 is of a type double. Double of the primitive type or an object type here in this double. It's a primitive type or an object type? Object type, because it has D capital. Okay? It's an object type. Its implement already compared to, so I can compare between D1 and D2. If you don't like this, you can replace this with double dot compare, and you give D1 and D2. But let us take this one implementation. So I forward the comparison to the double to compare between D1 and D2. How I can use it? Now I have compare two implementation that compare between York to D point based on the x-axis and then y-axis. Here I have to compare between York to D point based on the distance to the origin. See the difference between this slide and the previous one? Everything is the same except when I call collection.sort and I give the list. Here I give a new object of type, a new distance comparator. So now this sort method, okay, you want me to sort York to D point, a list that contain object of York to D point. How you want me to sort it for you? If I didn't provide a new distance comparator, we'll look at the compare to. But now I override this by saying, no, I don't need you to compare based on x and y axis. I need you to compare based on a new method, a method that I implemented on this class, distance to distance comparators. So now I define a class, I create a new object and give it to the sort. Now the object will be sorted based on the distance of the object. As you guessed the output, can you guess the output now? What would be the output after I sort them? Based on the distance. I'm sorting based on the distance of the origin. Which one is the very far away from the origin? It's very hard to calculate the Euclidean distance on the spot. Yes? X squared plus y squared under square root. Oh, forget the square root because it's common. So you can take x squared plus y squared. Yes? So we print the array unsorted. We ask the Java to sort the list for us, but now we need to sort the list based on the comparator interface, not comparable interface. And then we print it out. You see 1 and 1, 1 and minus 1, okay? Then 8 and 3, 9 and 3, then 2 and 15, because this is far away from the origin. So you see the unsorted is printed based on the order we inserted inside the array list. So once we insert it inside the array list, based on the order of the insertion, the array list will not change the order. So the first point we inserted to the array list was 8 and 3, and this is the first one we printed. The last one was minus 1 and 1, minus 1 and minus 1, and that was the last one is printed. Question? But you need one. Because we need to compare the distance of this point to the origin. You need to sort some object. If you didn't have a list contains an object, there is no point of asking to sort an empty list. So you need to declare a point and then add them inside the list. So you have some points inside the list, and then you are looking to sort these points. Okay? If you have a list with empty list, if you sorted and or you don't sort it, it's the same. It's an empty list. Okay? Okay. now this slide is very important just to understand that whenever you decide to create something, add something to the Java, you need to pass through the Java interface, or you have to do inheritance, or you have to do some kind of abstract classes. Inheritance and abstract, we cover it once we touch the topic of inheritance. And also polymorphisms is another way, and it's a common between two objects. So these are the construction ways, or 4 ways to construct an object inside Java. Interface, you saw now how we can create an interface. Okay, you already know how you create an object, but inheritance will allow you to extend the object, extend the behavior, add more fields. Abstract will allow you to define an abstract class that is meant to be a reference type, is not also to be create an object from the abstract class. Polymorphism is another way of using the same method but based on the declaration type. We can come across some details to discuss all the 3. Now, we will start now collections, how to use the collections. So Java contains a lot of collections, how they are organized inside the Java, and how to use these collections. This topic is not a new, most of you are familiar, but let us put it to make it more complete material inside this course. So what first thing is we discuss here is abstract data type. It's whenever you are defining a new object or defining a class inside the Java, actually you are creating what we call as an abstract data types. That is a grouping between the fields or attributes and the method and behaviors to inside one object. And we discussed this when we touched the topic of encapsulation. You have the behavior and you have the data, and you put them all in one unit, and you call it object by defining a class for in your applications. Okay, and then once you gather the attributes or the fields with the method together, you start treating this as a one unit or one piece of data. Okay, as you saw, car, it's as a one piece of objects. Bicycle as one piece of objects. Now, Java already, and not only Java, we have all the programmer language tend to have some kind of collections that easy to manipulate such kind of the same type of object. And one of the famous thing you already familiar with is arrays. You define an array of integers. You say all the element inside this array is integers. So this is a collections, okay, with int type. You define an array of doubles, okay. There's all element inside this array is double. So you try to do some kind of collection whenever it's suitable in your program, and that is allow you to easy to manipulate this set of data that are the same. You group them, all them in one objects. So the term is collections here we use, and normally we, as I mentioned, the arrays. Java has some kind of name is called collections to sort the object or similar objects all together, and we can sort them, we can search inside them, we can order them in some certain way, so it becomes easy to work with a set of the same objects. Okay, so all the abstract data types that come with the Java, they are inside this package, java.utility package. So if you want to decide to use a ArrayList or a set or a hash map or a hash set, you have to import java.utility. Okay? So sometimes people are think that the hierarchy or the organization that a Java is provided for the abstract data type is very complicated to understand. But actually, based on my experience, you end up with using one or two types that you are familiar with. You understand it very well. Okay, but today we will try to give a general overview for all the set of collections that is available, and then based on your practice you start using whatever you are familiar with. So we have inside the collection framework, we have a ArrayList, we have a linked list, we have HashSet, we have linked HashSet, and we have HashMap, classes are a part of the Java collections. And all of them is part of Java utilities. And we have a collection as a group of individual elements, and they have some kind of a certain rule to manipulate them. List, normally whenever we decide to use a list, like ArrayList or a linked list, so we are ordering the collection of value, allow the client to add and remove any element inside the list. Now, one of the famous example, as I mentioned, is ArrayList. List must hold the element in a particular sequence. That is some attribute whenever you decide to use a list or maybe other object. So if you are looking to hold the elements in some particular sequence, then it's good to use the list. List hold the object exactly as they are entered. As we saw in the previous example, the order you insert it to the list, it will be the order of the element inside the list. The list will not change the order. Set is unordered collections. So the order is not important. If you are trying to collect the object and you're not important for based on the order or sorting or based on the insertion orders, so set is the suitable collection that you should use. So, but there is one thing is very important to know about the set. Set will not allow you to insert the element twice. So it will contain only one copy of the element. Okay? So if you, for example, you want to maintain the students on the class, okay, you cannot use ArrayList because the students can exist in the class only once. Okay? So it's better to use the set. Okay? So the set will allow you to have the object only once. It will not give you an exception if you try to insert the element twice. It will be silent, but it will see if the element is the same on the list, it will not insert it. Okay? So it has its own internal sorting or ordering the element. So you might insert the element in such a way, but when you print it out, it will be different order, not the same as the array list. So if you are concerned with whether the element is there or not, okay, so not about the order, so you should use the set. But if you are really concerned about the order of the element and you don't care if the element is existed twice, use the list. Another type is called map. So we have list, set, and map. It's a structure that creates between association between the value and the key. And hash map is one of the famous category inside it. It's like a map. You look at the coordinates, you find some points, and there is a reference value for that point. Okay? So you define based some kind of index, okay, based on an index, and then you look for the value. So map is a group between key and the value. So you have some kind of key. Like you, for example, you have the, in your phone, you might not memorize all the number of your friend, but you already write their name. So you look at their name, if you press the name, you see the phone number, okay? This is some kind of sort of hash map. So you sort them based on the key. Here is the name because you are familiar of recognize their name. You're not keeping your memory all their numbers, digits. Okay? So you find the phone, you press the name, then you find out the actual digit value for the phone number, your friend. So the map can retain a set of its key or can retain a set of the values that it contains. Okay? Now, if you look at the hierarchy is start with an interface called collection. That is the top of the hierarchy. It's called collections. Under it, there is another interface. It's called the list interface. And there is a set interface and also abstract collections. Now, there is abstract list that implement the list and abstract collections. Under the abstract list, we have array list and linked list. See the hierarchy here? The array list actually is implement, the interface is called list. And linked list is also implement the interface called list. Under the set interface, we have abstract set that is implemented. We have hash set is implement the abstract set, which is implement the interface set. Also, we have tree set. And also, we have another interface that implement the set interface is called sorted set, because we know that whenever we have a set interface, the order is not important. But they make another interface called sorted set, which is implement the set interface, okay? And that is allow us to have a order or sorted set. Now, from your experience, now we have a list as an interface. So what is inside the list here? It's some set of methods. Some set of methods define the behavior for any object that is implement this list. And one of the objects that is implement this list is ArrayList. Now, map, we have abstract maps that implement. We have a hash map, and we have a tree map that also implement a sorted map. So you cannot create a new map. You cannot say new map, new set, a new list, because list, map, and set, all of them are interfaces. We cannot create object from interface. We create an object from ArrayList, hash set, hash map, but we cannot create an object from map. We can use map on the left side as a reference type, but we cannot use it with the new keyword. This is another way of viewing all of this. Also, we have a utility. Don't get confused. Here is a collection interface. Here is a utility called collections. So there is a collection as an interface, and there is a collections as utility class. And all of them, they have comparable and comparators. So before I start dig deep on collections, I will touch this topic and I will come back to it when we have the inheritance. But it's good to know, because some reference on the reference textbooks or in the library, if you go to read more about the collection or how to use the collection on the Java, they start with this wildcard. And they start with using it, so you will get confused about it. But today I will introduce it for you quickly, and I hope this will help you, even if you read some online resources, or you go to the library and open any book who use wildcard to explain the collection, you will be able to read that book. Normally, wildcard is used with collections, whenever we are trying to use the collections. So you remember the collection can hold any objects. You say, I define array list of chairs, array list of cars, array list of tables, array list of doubles, integers, strings. So I can hold any objects. So this is a collection. All of them is a generics. Okay, they can hold whatever you already decide to put inside the array list or inside the hash set. Here is, for example, you have a public void method has a string as a one argument, and the other argument is array list, and there is a question mark inside the triangle brackets. And this is argument 2, is saying that I will give you array list of any type. Okay, which is equivalent to say I give you array list of T capitals. So if you see a question mark in some reference, this is what we call a wildcard. So you put a question mark to say I will give you an array list of any type. It's the same as if you take this array list with this question mark and you put array list between the triangle bracket T capitals, because that is T capital is be any type, is a generic type. Okay, is this up to this point? Do you have any confusing about wildcard? So this is a question mark and T capital, they are substitute each other. Do you have any question? So all the topics that we discussed about generics, and we just put take T capital and put a question mark. Okay? So nothing changed. So array list of any type, either I can say array list between the triangle brackets, I put T capital, or I say array list between the triangle brackets, I put question mark. It's the same thing, saying that I give you any array list of any type. Here I can give array list of integers, doubles, whatever I need. Yes, yes. Java will understand the question mark as a type called wildcard. Okay, it can carry anything. Okay. For this example, you see it like this. If you use it the same as I'm using it in the slide, yes. Okay, because T capital is generic type. You can replace T capital with any type, with your 2D point if you want. Okay, you can replace it with a car object. Whatever object you like it, you can replace T capital with it. Here I can replace question mark with any objects. Now, there is another now is an extension of this wildcard. It's saying that I give an array list with some kind of ancestry bounding or descendant bounding. I'm saying that I will give you all the objects that has some common parent, or I give you all the child of this object. Okay? You start making some more constraint about the type of the object, not only just a question mark. You start saying, I will give you an array list. Let's say a furniture, chair, table, okay, lamp, all these are furniture items, yes? So you say, I will give you all a furniture item. That means I give you an item, they have the same parent. They are furniture. Okay? Good? Or you can say you define a student as a student, but then under the students, you have ECS students, electrical engineering students, civil engineering students. Then you want to say to this method, I want to give you an object has the same parent. Okay? Object, they are all students. So that what is the more constraint. That's why the wildcard is more famous on the expert Java programming or advanced Java programming than the generic. Even the generic is used wide. Many people are using generic type. But the wildcard is give you another opportunity to say about the type that I'm giving to you, to make more constraint, to make the type more specific. Let us see. I can say between the triangle brackets, question mark, that I'm going to send you any type. But extends string, that this object that I'm going to give you to has the parent of a string. What is the parent and how they extend, all this will cover in the inheritance. But I'm covering this topic here to give you a highlight what is the wildcard is. And that will allow you to read any reference. Okay? So, question mark is like T, capital. But here I put more constraint. I give you a question mark, any type, but extend string. So I can say like this. List, triangle brackets, question mark, extend string. So that means the content or the objects of some unknown type extend string. I didn't specify what type of object that I'm going to give it to you, but as long as it's extend the string. I can say a question mark superstring, that I'm going to give you an unknown object that has superclass of a string. How this is can be, look at this hierarchy. You can here see this. A is a what? Is the root. That means A is the superclass. But A is a superclass for P and E. Yes? But C and D are child or extending P. P extend A. That is the hierarchy. P extend A. E extend A. That means A is a super for P and A is a super for E. But F is a child or a subclass from E. G is a subclass from E. So what is the parent for G is E, but what's the parent for E is A. Okay? So whenever you say question extend P, that means you are saying that I can send to you P, C, D. You see how much has become more? It's not simply T capital, I take it and replace it with A. Now I have a wildcard. That's why it's called wildcard. I can question mark, replace it with A whenever I have in my program, replace it with C. I just define it only once. And whenever I decide to use this list, I can put A, but P, C, or D. Because I decide that question mark extend P. Yes. Yes. Will work for all the hierarchy. But it's become more like you define an array list that can contain every element extending A, including A. Now, this is question mark super G. All the super of G. What is the super for G? Is G itself, super of itself. E is a super for G, and A is a super for G, yes? So I'm saying that I can define a set contains question.super of G. You see that the difference between the generic now? A question mark alone is the same as T capital. But a question mark with extends some type, question mark with super type, so we'll make a little bit more constraint about the type. Any question? This is all what I need you to know about the question mark, or what we call it a wildcard. Okay? Now we will dig deep on the list. If I didn't cover all the material here, most of this material you are familiar with, okay? And I will put the slides on the Moodle. You go over this slide. If you have any question, you can see me and ask me. But these materials, I'm not going to go back to it, okay? Because it's about how to use it. And I think most of you know how to use it, because once you put list dot, you will have get. But we will see now. You will see what I mean. So in real life, you have a company may maintains a list of employee, a bank list of bank accounts, person list of things to do. So a list is abstract data types that can insert and remove elements. So inside the list will automatically shift the element around the memory to make need for the room. So the list, that is the beauty of the list compared to the arrays. Arrays, when you define it, is a fixed on the size. You cannot extend the array or shrink the array. Either you have to destroy it and build it again. But in the list, you can shrink it. You can extend it easily. Okay? So the list is abstract data type, implement the order collections of elements where the same value may occur more than once. So you can insert inside the list the same element more than once. We use list whenever we have the element come being removed in random orders. You can use it, the list. You can use the list. The element are general is sorted in particular positions, which is the position they are inserted with. And you can use index like the array. Like give me the element at index 3. We retain the element at index 3. So you have this method, add index. Now we're discussing the list. Remember, we're discussing the list. List is what? Is an interface. So the list is an interface. So in the list interface, we have add, we give integer, index, and we give an object. That means we add the object x at index, and now we shift all the elements at index +1 until we increment the size of the list by 1. Now, this is an example. You have a list, add 2 and x. You just go to the index 2, insert the x, and all the element is shifted, as you can see, to the right. Remove from a certain index. You give me the index. You want to remove the object. I will retain the object back to you, but I will reduce the size by 1. Simply remove element at index 2. It will retain 9 in this case, okay, before. After, you can see the element is removed and the list is reduced in size. Set you give an index as an argument and you give the object as a value, okay? And now you go to the index and you change the object at that value. Here we have object set to x. We go at index 2. We have 9. We replace it with x. The size of the array list is the same. No change on the size. Get is not remove. It's different from remove. Remove will take the element out of the list and reduce the size. Here is just retain the element from the list. We have array list. Get 2 will retain the element at the index 2. Size will retain what? The number of element inside the list. Okay? All of these is a behavior method or a method that exists inside the list interface. Now ArrayList implement this list interface. So I know from the relation between the ArrayList and the list, because the list is interface and the ArrayList is an object that implement this interface. So all these method is already implemented on the ArrayList. So I can do get, size for the ArrayList, remove for the ArrayList, set for the ArrayList. I can do that. Clear. What do you think clear? Clear will what? Remove the element from the ArrayList, will not delete the ArrayList. That is what most of the people got confused. Will not remove the ArrayList, will clear, will just remove the element inside the ArrayList. The ArrayList object exists in the memory. You can add another element to it, but it's clear. That means remove all the elements. So still we have the ArrayList, but we clear all the elements inside it. Add object, insert x at the end of the ArrayList. So if you have ArrayList and you say add object x, always will be inserted at the end, and the size of the ArrayList will be incremented, or the list will be incremented by 1. Remove object. I just don't say remove object at a certain index. Just remove object. It will look for the list in order, and the first occurrence of the object will be removed. Will not remove all. Assume that the object has duplicate. The ArrayList has duplicate object, or the same object exists inside the ArrayList more than once. The first occurrence of it will be captured and removed, and the size of the ArrayList will be reduced. Assume that here we have to remove 9. So we remove 9 and we reduce the size. If there is another occurrence for the 9, will stay on the ArrayList. Okay? Index of object, retain the first occurrence of the object. Here the 9, we retain that is at index 2. If there is a 9 at index n minus 3, it will not, we don't know about it. Okay? We know about the first occurrence of 9. Is empty is another test to determine if the ArrayList is empty or not. Contains object. You check if the object exists inside the ArrayList, and will retain true if the object exists. Otherwise, we retain false. So yeah, as you can see, this is about more like most of you are familiar with. If you're not familiar with, even if you put dot clear and there's a description will be printed on the clips, you can read more about it. Okay. So the ArrayList is another data structure that implement list, that I assume that all the method I discussed on the previous slide is already exist for the ArrayList. So the difference between the arrays and ArrayList, that all the operations, okay, are based on the method and the ArrayList, and you can grow on the size for the ArrayList, while the arrays is fixed in terms of size, and we are using get and set. You cannot insert without using get and set. That's why all the methods are controlled by, all the operation is controlled by methods. So we have a method inside the ArrayList. There is additional method inside, is a Boolean add. We have a generic type, T capital. Now, T capital and the question mark is the same. So T capital and element, I give an element and insert it inside the ArrayList, add it to the end of the ArrayList, and I will retain always true, if that's add at a certain index. So you see here now it is a generic type. is used because the array list can hold any generic type. We add it to the same index. Remove from index, we retain the generic type, T capital. Okay? And remove also, we remove the element from the array list. Again, is a generic type. Clear will clear all the elements from the array list. Size will retain the size of the array list. This is inherited from the implementation of the interface. So because we decide to implement the interface list, so we have clear and we have size. Get at a certain index will retain the generic type, T capital. And set will change the value at a particular index. Index of a value at a particular, we retain the first occurrence of the object. Look here is all these, when we come to the array list, we have in the list, we use object. But in the array list, we use generic T. So contains a value of a generic type and is empty, will decide if the array list is empty or not. So to use the array list extend the abstract list, okay, and implement the list interface as we discussed. So we have a class called ArrayList, and you can see here between the triangle brackets we have E. E is a generic type, stands for elements, okay? So ArrayList, this is a constructor of ArrayList, either to decide to make a constructor of an empty, either to say ArrayList of a collection of a type, a generic type, or a wildcard extend E type, and now you can replace E as a generic type with any type you need. So it will start the array list with some kind of previous collection. If you have already previous collection is created, you want to construct the array list from that previous collection, you can use these constructors. Or you can use array list with some integer capacity. You can say, I need the array list, empty array list, but with some initial capacity 10 elements. Okay? That sometimes we use because array list is extending the memory. So we need this element to be closed on the memory set initial locations or initial elements. So this is an array list at this index, and these are the names inside the elements. Now, for example, if you want to initialize or declare the array list, you use the array list. You put between the triangle bracket string. That means this array list has a reference type of array list names, and then a new array list. You create a new object from the array list. Based on the previous discussion, I can replace this array list in the reference type. I put only list because list can be used as a reference type. Okay? The advantage of specifying the element type in the Java can be known what the type of the value inside this array list, and also we know that the generic is provide the compile time safety for us. So the restriction on the generic, and we discussed this in the previous, is about, you see here, we define the array list of a string. Okay? We create a new object of an array list. This is illegal is become to write array list of integer. Why? It's written on the slide. Why? Because int is a primitive type. We cannot use it inside the array list. We cannot create. We have to create an array list of objects. Okay? We know that the generic can be used for the objects, so we cannot use the array list of primitive types. If you decide to have integer, it's better to use the wrapping class is integer, the big name integer with I capitals. So Boolean, that is a Boolean. These are the primitive types and the wrapping class for each primitive type. If you want to create an array list of characters, it's better to use not char is characters. And now Java is support what they call boxing and unboxings and auto boxings. So you have the array list of integers, you define it, and then you add 42. The Java will take 42 and put it inside the integer object and insert it inside the array list. And whenever you decide to list.get 0, get the element at index 0, the Java will take the integer object and retain the value of that integer object and assign it to int answers. So here what we call a boxing, take the int 42, put it inside the object integer. That's what we call a boxing, because you take int as a primitive type and put it inside the object of integers. Unboxing, you take the object integers, you retain the value of that object, and you assign it to a primitive type of type int. So that what is boxing and unboxing again. Now it's become automatic. Java is supporting it. You don't need to do it explicitly. Okay. Normally in the past we have to use a new integer and to give the value. Now we have this is automatics for the boxing and unboxing for all the primitive types. And here we just give an example. Okay, you have the array list. You start defining the array list. You print the size. You add some value to the array list. Okay, you retain the size of the array list. Okay, and you add the element at index 1. Okay, you're supposed to shift. Then you print back the array list. So you can see here that once we define the construct the array list, it has size of 0, empty. Okay, and once we add 7 element, the size becomes 7. And look at the last line here, add 1 comma collections. We'll add the collections to the element of index 1 and shift the rest to the right. Okay. Now remove element from the array list. Remove element at index 2. I can use that. So once I decide to remove the element, I print the size, array will be removed, and also I remove the element at index 2. The index 2 will be removed. So these are examples of about how to use the array list. Now another class is linked list. Okay, again the topics inside these slides. Okay, it's for you to read it. It's mandatory to know them. Okay, they will be part of the lab test 2, lab test 3. Okay, and also it will be part on the final. It's more like I put it here as a material to make the material, the lecture note more comprehensive, include everything. Okay, as you saw, we go through the array list, discuss the operation of the array list, but most of you, whenever you decide to use, for example, the set, go to the set. This is the set. Okay, this is the hierarchy for the set. Set is give you the order. Is there's no order inside the set. The most important is there's no duplication of the element. How to use the set? Okay, how to use the set? Just simply define set of element, then dot will give you all the list of the function that you can use for the list. Now, how the set determine if these objects are identical, so they're not allowed duplication, they will rely on your implementation of equals. And if you remember at the beginning of this course, we mentioned that if you decide to have an object or you create a class, you have to provide an implementation for the hash code and for equal. Why? Because if you decide to use this object inside any collections, okay, the implementation, if the implementation is broken, that means you miss or you forgot to implement the hash code or equal, you will not be able to use these collection in the right way. Okay. For example, if you want to use the set for your object, you should provide the implementation for the hash code and equals. So the set can determine if these elements are the same, so we're not allowed the duplication inside the set. So the difference between the set and the list is the order. The set does not keep any order, okay, while the list is keeping the element in order. Add object, remove objects. There's no index inside the list because I don't know what is the element on the list. Add operation will not allow you any duplication of the item to be added. It will not throw the exception. That is the most important thing here. We're not going to see any exception. If you're adding the element, which is the same as the element inside your set, will not see any exception. Okay? HashSet is a class that implement abstract set and also implement the interface, extend the abstract set and implement the set interface, and also use what we call a hash table, as we discussed in the previous lectures, that the hashing help us to do the search. By equal. Yes, whenever you decide to create an object, if you decide to use the collection of type set, you have to provide the implementation for the equals. When they provide the implementation for the equal, you decide how you see that this object is the same. For example, the chair. You decide that this is an object of chair. If you provide the implementation for the equal, you say, I will compare the chair based on the weight. So the two chairs are equal if they have the same weight. Other person say two chairs are equal if they have the same colors. Okay? One say if the chair are the same if they have the same number of legs. Okay? So how you are decide that your object is the same. Okay? You decide to create an object of a laptop. You say, I will compare two laptops based on the amount of the RAMs inside them. Okay? That is the equal. Then the set will not allow you to insert a duplicate element. If two laptops with the same RAM are trying to be inserted, will keep only one copy of it. So we define a class HashSet, okay? And the hash code is automatically generated for you, and it will rely on the hash code implementation for your object. So if you have a class of type chair, you decide to implement a chair class, you define the hash code for the chair. So the hash map or hash set will use the hash code for implementation. We have add, contains, remove, and also the size of the hash set. So efficiency of the hash set need the implementation for the hash code. If you not implement the hash code correctly, or you have, let's say, someone decide to implement the hash code, always retain 0. So all the element will be having the same hash code. This is not efficient. Okay? So you have to come up with the implementation. And now Eclipse is allow you to just have some default implementation for the hash code. If you can change it if you decide this implementation is not suitable for you. You can create a hash set by using constructor, hash set and empty constructors. You can start hash set from another collection. You can start a hash set with some capacity, and you can start with some capacity and fill ratio. Whenever you reach the fill ratio, by default is 75%. Whenever you decide to, the default capacity is 16, the fill ratio is 75. So if you become more than, if your hash set is become full more than 70%, the Java will up extending the array hash set, resize upward. Okay, so by default is 70%. Okay, 75%. Okay, I will stop right now because I will discuss another issues. Okay, again, I'm going to repeat this. The rest for this slide is about how to use the hash set, hash maps. Okay, it contains another examples also. It's good to read them. It's good to be familiarized with the collections and how to use them. The next lectures, I will touch a few topics from this slide. Then I will start a new